Welcome to XStore Point of Service. Today we're going to talk about the services framework. In this session, you will learn about the framework that XStore uses to interact with external web services, service handler configuration and implementation, request response adaptation, and exception handling. In versions of XStore before 7.0, the definition of the services that were available to XStore was controlled by numerous classes, property files, and configuration files. Adding a completely new service provider proved to be so complicated that doing so was usually avoided, and alternative methods of accessing some service were sought within customer overlays. That is a shame because XStore Service Framework is rather powerful and flexible to be able to handle many different types of web services with default or abstract handlers for both WSDL-based services via the JAX-WS or straight good old build-it-yourself raw XML communication. In an effort to eliminate the initial setup complexity and make the service framework more approachable, all of the classes and property file facets were eliminated in favor of Spring-configured beans. So now we're going to talk about the service handlers. Configuration of web service endpoints is managed by the file servicehandlers.xml. The general idea of how to configure a service handler has not changed since XStore started. There are different service handlers.xml for each service provider. I will show you a file which we are using for the customer engagement, service handlers.xml. So now we're going to talk about service handlers. Configuration of web service endpoints is managed by the file servicehandlers.xml. The general idea of how to configure a service handler has not changed since XStore started. I will be showing you later on what the service handlers for a customer engagement looks like. And XStore provides a Spring services-xxx.xml file for each provider, where XXX identifies the provider. So here the provider can be customer engagement, order broker, RXM or SIM services. The service port information here includes the service ID, service interface, namespace URI, service name, port name, username, password, and etc. Beans in files define classes for individual service methods as well as service API implementation classes and persistence strategies unique to specific service providers. Here is a sample configuration of how it looks like in services-relate.xml file. As of XStore version 15, the implementation and obtaining of service handlers has been given an overhaul. The remaining pieces have been converted to be Spring managed. The type hierarchy of abstract classes has been rearranged, and additional typing information has been added to make it clear with less guessing what the purpose of a specific handler is. Service handlers for WSDL-based services that wish to utilize the common processing code of the abstract web service handler no longer needs to be adaptation-based. They can simply extend abstract web service handler class. This greatly simplifies the ability to implement the integration to a basic WSDL-based using JAX-WS. The service handler interface had type parameters added to it that represents the type of service request that the handler expects and the type of service response that the handler returns. This eliminates a lot of unnecessary casting within the handler, and it makes the contract of what the handler is supposed to do very clear both to the implementation and to the caller of the handler. To really drive home the idea of the service handlers being typed, obtaining one from a handler factory involves the use of a special class called service type that also specifies the same request and response parameters. The service type is similar to the value key, but a bit simpler. Using this ensures that the service handler that is obtained from the factory handles the intended service request and response. To make it easier to reference service types for the base services, all of the available types for a given provider are defined in one class that is specific to that provider. The pattern is similar to the one that is represented by value keys. There is like a relate service type class for all CE services that are available, and locate service types for all order brokers. Here, you will see in this class that we have all the relate service types. So we can expect like for this to have like the attribute request and the attribute response service type coming from the handler. It is anticipated that if a customer wants to implement the integration of an external service provider, this same pattern should be followed. The concept of a service provider class, a service factory class, a property to identify a service class to use no longer exists. Instead, beans that represent the actual service implementations are defined in the services.xml Spring file. The service implementation to use when in training mode also appears in this file. All service implementation beans that are defined should be assigned to maybe training mode scope. In order to add a new service, simply create the interface and implementation class for it, configure the bean in the Spring XML file, and inject the interface with the provider in any class where it is needed. To override a service implementation, configure a bean in the Spring file in a customer overlay to have the same ID as the bean base and provide a different class. For service implementations, the implementation override class does not need to extend the base implementation class. It only needs to implement the service interface. Injections of services into XStore client-side classes should reference the service interface and never an implementation class. So here I will show you a sample of relate service defined in the services_relate.xml file. In this bean definition for customer services, the customer services impl class is the service implementation class which implements its interface iCustomerServices class. iCustomerService class must then extend the iService class. In order to use this service bean, simply by injecting the interface with a provider class to any class where it is needed and use it to achieve getting the method you wish to use. As you can see in this customer helper class, we are injecting the interface with the provider to the class where it is needed. So then we can use this when we want to use this for getting the method, then we use the customer service.get and the method where we need to call the web service. Now we will talk about the request response preparers and adapters. Request response preparer classes are classes that extend the abstract preparer class and prepare getting the response objects from the provider ready for adaptation to a newly instantiated XStore's object and vice versa. While response adapter classes are classes that extend the abstract adapter, which from the name itself adapts meaningful data into the expected XStore objects to be used and vice versa. Both the preparers and adapters are Spring managed. Along with being converted to Spring beans, the advantage of configuration inheritance is gained. Lastly, we will talk about the exception handlers. Exception handlers are also currently Spring managed. Again, having this converted to Spring beans gives us the advantage of configuration inheritance. This means that base exception handlers are configured as children of the standard service exception handler bean, which allows them to inherit the properties of said parent. More importantly, the error handler that is configured on each exception handler bean is a child of the standard service error handler bean, which gives it the inherent to detect both an inability to reach an external service and a timeout and respond appropriately. Any error handler bean definitions that are added in both the base and in customer overlay should have standard service error handler as a parent. With being converted to Spring beans comes the notion that exception handlers are now directly associated with a service handler bean. With being converted to Spring beans comes the notion that exception handler is now directly associated with service handler bean. The exception handler is configured by specifying the exception handler property on the service handler bean definition. Note that every service handler is required to have an exception handler configured on it. Note that the only code that had to be written for this implementation of this service method was the service handler itself, and that only involved the taking information from the service request, making a method call with it, building a service response with the results if the call was successful. All of the implementation of the communication exception handling is handled by existing code and configurations. What we are looking right now is the services_relate.xml file, and we can see that there's a customer retrieve handler class where we need to send out a request to relate. So in order to send request to relate, we need the request preparer and request adapters. So this is where we transform or instantiate a relate object when we do the preparer. And in the adapter, what we will do is convert the XStore or adapt the XStore data into the relate object and then send it out to relate. Of course, when we send out a request, we will get a response. So when we get a response back from relate, it will be in the form of relate object. So in order to transform this again to XStore side, we will be having a response preparer where we will instantiate the XStore object and then the response adapters where we will convert or adapt the relate objects into XStore objects so that the XStore can use it. So when we send out a request to a customer engagement, of course, sometimes we will get exceptions. So this is where the exception handler comes in. As I have discussed earlier, we will set it in the attribute and then put in the class or the Spring Bean class for it and handle the exception. This concludes our session on the XStore Services Framework.